Hello. In the first lecture of this course, we take an overview of the octal number system. In this video, we will take more details about the octal number system. The octal number system provides a convenient way of converting large binary numbers into more compact and smaller groups. The binary number system is a base 2 number system since it only uses the digits 0 and 1. Octal is a base 8 number system since it uses 8 digits 0, 1, 2, 3, 4, 5, 6, and 7. Binary and octal numbers are often used in computing applications, so it is common to need to convert from one to the other. The base 8 system is often used in legacy computing applications because a single octal digit can represent 3 binary bits, which are cleanly divisible in 6, 12, 24, and 36-bit computer systems. So in this table, we typed all digits of the octal number system and it is equivalent digits in binary. Let me show you where we got these equivalent binary numbers. As we know, the binary number has the base 2, and we did study how to convert the binary to decimal, and this is the same way, where the digits in binary are written in decimal from left to right as 2 to the power of 0 is equal to 1. Then 2 to the power of 1 is equal to 2, then 2 to the power of 2 is equal to 4. So, the number 0 is consisting of nothing, so we put 0 in the first place, 0 in the second place, and 0 in the third place. The number 1 is consisting of only 1, so we put 1 in the first place. The number 2 is consisting of only 2, so we put 1 in the second place. The number 3 is consisting of 1 and 2, so we put 1 in the first place and 1 in the second place. The number 4 is consisting of only 4, so we put 1 in the third place. The number 5 is consisting of 4 and 1, so we put 1 in the first and third places. The number 6 is consisting of 4 and 2, so we put 1 in the second place and 1 in the third place. The number 7 is consisting of 4 and 2 and 1, so we put 1 in the first, second, and third places. Let us take an example. Example 1. Convert the octal number 63.4 to a binary number system. From the above table, the octal number 6 is equal to 110, the octal number 3 is equal to 011, and the octal number 4 is equal to 100. So the octal number 63.4 is equal to 110011.100 in binary. Let us take another example. Example 2. Convert the binary number 1101011.11011 to an octal number system. First, we will be grouping the binary digits of 3. We start with the integer part from the left of the decimal point and take these 3 digits. From the table, these digits are equal to 3. Then we take the next 3 digits. From the table, these digits are equal to 5. Then we take the last group, this one, and we will assume there are 2 zeros to the left of this one, where these 2 zeros are not changing the value of the number. So from the table, this group is equal to 1. Now we convert the fractional part and starting from the right of the decimal point with these 3 digits. From the table, these digits are equal to 6. Then we take the last group or the number, these 2 ones, and we will assume there is a 0 to the right of them, where this 0 is not changing the value of the number. So from the table, this group is equal to 6. So the number is equal to 153.66 in octal. This course is sponsored by the Logic Kit app, where this app is made for teachers and students that are involved in studying the computer. With the Logic Kit app, you can learn and solve number system and Boolean algebra with step-by-step solutions. I will leave the link to download the Logic Kit app from the App Store in the description. Don't forget to subscribe to the channel, follow us on Facebook, and visit our website. All links are in the description.